Hello students, good afternoon everyone. This is Ram Soro, your maths faculty. I welcome you all to Turito live classes. Children, today we are going to discuss about, children, what was the last class? Did you remember anything, children? So what we discussed in the previous class? Children, in the last class we have discussed about the introduction of real numbers and division algorithm and Euclid division lemma, and we are finding the HCF of the two numbers by using the word a division algorithm lemma. So this was the previous class, children. But today's class we are discussing about what we are learning today. The first thing is what? The fundamental theorem of arithmetic. That is the first point. And second one, introduction of LCM. Children, is already you learned in the previous classes, but still you are learning a little bit more information regarding this LCM. Okay. And methods of finding the LCM, like how many methods we have generally to find the LCM of two or more numbers. Okay, so those things we are going to learn today's class. Fine, children. So these are the today's topic, like learning objectives of today's class, and some problems related to what? Finding the LCM of. Next, the fundamental theorem of arithmetic. So what is this fundamental theorem of arithmetic? So what actually it is exactly? Any idea, children? So what is the fundamental theorem of arithmetic? So very simple, children. Let us see here. Every composite number, you can take any composite number. Okay. So every composite number. Children, what is the composite number? Any idea? So how we can define the composite number? So what are the composite numbers generally? Can I say 6 is a composite number? Can I say 9 is a composite number? Can I say 20 is a composite number? And can I say something 50 is a composite number? Tell me, children. Yes. These are all the examples of what, children? A composite number. Okay. Generally, a composite number means a number has more than two factors. If a number has more than two factors, we can call them into what? A composite number. Clear, children? If a number has more than two factors, we can call them into what? A composite number. Okay. So I can say 6 is a composite number, 9 is a composite number. You can take 20 or 100, anything, children. So these are all numbers. Example for what? A composite number. Okay. Fine. Children, can tell me what is the prime number then? So prime number means it has exactly two factors. One and itself. You can take one example, children. You can take 3, children. Can I say 3 is a prime number? Yes, 3 is a prime number because 3 has exactly two factors. So it is divisible by 1 and it is divisible by 3. So apart from these two numbers, you cannot divide this 3, isn't it? So I can say 3 is a what? A prime number. So prime number means it has exactly two factors. So those numbers, you can call them into what? A prime number, isn't it? Okay. Now what is actually our theorem, children? The fundamental theorem of arithmetic. So what exactly it says means every composite number can be expressed. Here expressing nothing but what, children? Factorizing. Again, what is the meaning of factorizing again? The whole number, we are writing what? Product of its factor, product of its factor and product of its factor. So that expression we can call what? Factorization. Factorized as product of its primes. First point. So how we are going to express means by using its prime factors, and this factorization is what, children? It is a unique combination. Unique means what? It is a fixed. You cannot change. So that is called what? A unique combination. Apart from the order which the prime factor occurs. Children, listen here. It's a very simple. I am taking the one number, children, 24. Can you tell me, children, how we can write 24 as a prime factors, like product of prime factors? So 24 we can write as 2 into 2 into 2 into 3. So I can write as 2 into 2 into 2. So it is what? A 2 to the power of 3 and this is 3. So it is what actually a prime factorization of 24, isn't it? Children, this 2 to the power of 3 into 3 is a what actually the prime factorization of 24, isn't it? So this combination is actually what? It's a unique combination, children. This is actually what? A unique combination, and it is a fixed. The order may change. Some people may write 3 as the first and 2 to the power of 3 is second. And some people may write 2 to the power of 3 is the first and 3 is a something second number. Okay, the order may change from a person to person. But the thing is what, children? The combination is fixed combination. That is called what? A unique combination. So that is will not be changed. But the order may differ to person. Is it clear, children? So that is actually what? The fundamental theorem of arithmetic. Children, let us see another example. Children, I am taking something as 26. So how we can write, children, 26? Can I say 26 is a composite number? Yes, it is a composite number because it has more than 3 factors, isn't it? Now tell me, children, how we can write 26? I can write as 2 into 13. Okay. So this 2 into 13 is a what, children? It is a unique combination. This combination never be changed. It's a fixed combination. But the thing is what? The order may change. You can write as 2 into 13 or you can write as 13 into 2. So the order may change person to person. But the thing is what, children? This combination is always fixed combination. Okay. So that is called what? The fundamental theorem of arithmetic. Clear, children? Any doubts regarding this? Fine. Now children, what I am doing? I am taking one number, children. So I am taking A is a one number. Some composite number I am taking. A is a composite number. So it has some prime factors. You take it is a P1 is a one prime number, P2 is a prime factor, and P3 is a prime factor, and P4 is a prime factor, and so on. I am taking up to n. So A has n prime factor, that is P1, P2, P3, P4, and so on Pn. So prime factor means what we can do? If I multiply this all prime factors, I will be getting the given number is A. So what I am writing? A equal to, tell me how we can write? Multiplication of P1, multiplication of P2 and P3, P4, P5 and so on up to Pn. So that is what this complete number I am expressing as by using its prime factor, that is P1, P2, P3, P4 so on up to Pn. Isn't it? Now think that, children, these all are different, isn't it? They may be same or they may be different. So how we can write in ascending order? That is P1 is less than or equal to P2 is less than or equal to P3 is less than or equal to P4 is less than or equal to P5 and so on. So this is what? P5 is less than or equal to what? So on up to Pn. So what we call, children? It is the fundamental theorem of arithmetic. Okay. Any clear, any doubt, children, regarding this fundamental theorem of arithmetic? It's a very simple, children. You can understand by very easily. So what is actually this fundamental theorem of arithmetic? Every composite number can be expressed as product of its prime factors. And one more thing, what, children? This combination is what? A unique combination. It is not going to be changed. That is the first point. And what is the second point, children? The order may change. Like the order how you are selecting the prime factor, that may change. But the combination is what? Always a fixed combination. So that is called what? The fundamental theorem of arithmetic. See, children, any doubts regarding this theorem? It's a very simple theorem. You can easily understand, children. There is no issue regarding this theorem. Isn't it? Fine. See, children, the same thing I am writing here. I am taking A is the one composite number. So this A we can write as product of what? Its prime numbers like P1, P2, P3 and so on up to Pn. If I write all these factors into what? Something ascending order. Ascending order means a small number to bigger number. So how we can it be written? So P1 is less than or equal to P2 is less than or equal to and so on Pn. Okay. So generally we can write the order is what? Ascending order. So that is why I am writing P1 is less than or equal to P2, less than or equal to P3 and so on up to Pn. I'll give another example, children. You can take something 48. So how we can write 48 as a prime factors? Do the prime factorization, that is what? 2 how many times? 24 times, and 2 how many times? 12 times, and 2 how many times? 6 times, and 2 how many times? 3 times. Okay. So this we can write as 2 to the power of 4 into 3. Otherwise you can write as 2 into 2 into 2 into 2 into 3. So this 2 is what? A prime factor and 3 also prime factor. So I am writing what, children? Ascending order. So whenever you write the prime factor, so try to write in ascending order. Clear, children? Okay, I'll take another example so that you will understand better. I am taking 30. So how we can write 30? So it is 2 15 times and it is 3 5 times. Or you can take 5 one time also. Then how we can write 30, children? 30 I can write as 2 into 3 into 5. See what I am writing, children? I am writing all the factor into ascending order. 2 into 3 into 5. Okay. So whenever you are writing that the prime factorization, children, try to write all the factor into ascending order. So that is the condition we are writing. P1 is less than or equal to, P2 is less than or equal to, and so on, less than or equal to Pn. So that is the what? The representing of what? Its factors into ascending order. So try to write all the factor only in ascending order. Is it clear, children, everyone? Okay. Next, children, let us see one example. 140. So what is the question? Express 140 as product of its prime factors. Now, children, how we can write 140? First, do the factorization of 140. So, do the prime factorization. So, prime factorization means we have to select only prime numbers, isn't it? First, start with a first prime number. What is the first prime number? 2. And check it whether it is divisible by 2 or not. If it is divisible, go for 2. So, I can say it is divisible by 2. So, I am writing 2. So, 2 how many times? 270 times. Again, I can take 2 table and 2 how many times? 35 times. Children, 35. 35 is what? Not divisible by 2. So, go for 5 table. So, I am writing what? 5 sevens are. Then write as 7 ones are. Now, what I am writing, children? This 140 I can write as 2 into 2 into 2 into, sorry, only 2's no. So, we are writing extra 2 also. So, into what? 5 into 2. See, children, I am writing all the factors into what? Ascending order. The first factor is 2, again repeating is 2, again 5, again 7. So, this we can write as 2 less than or equal to 2 less than or equal to 5. So, this is 5 is less than or equal to, this is 7. So, this is a way we can represent all the factors of any composite number. Clear, children? Any doubts regarding this example? The example is very simple, children. First, I am finding all the factors of the given number, and those numbers, like those prime factors, I am writing into what? A ascending order. Ascending order means what? A small number to bigger number. Clear, children? Any doubt regarding this question? No. Okay. Next one. Let us see one other example, children. So, express the 3825 as a what? Product of its prime factor. Children, you can try this as your own. Take the number 3825 and start with what? A prime factor. Otherwise, we can do it directly now. So, 3825. Children, I will go with directly a 5 table. 5 how many times? I will go 5 sevens are 35. 35 means 30. So, 32 means I can go 5 6 are. So, 25 means again 5 5s are. Again go 5 table. So, this is what? A 5 ones are. and this is what 5 ones are 1. 26. 26 means we can go 5 5s are. Again 5 5s are. Okay. So this is what 5 ones are 5. So 2 means 26. So this is what a 5 5s are and 5 3s are. Again go for what a 3 table. So this is a 3 1s are. So 3 5 3 1. We can go 17 table. 17 3s are. So how we can write children this? This we can write as 5 into 5 into 3 into 17 into 3. But it is not in ascending order. So write in ascending order. So 3 into 3 and this is 5 into 5 into 17. So this is ascending order of all the prime factors. See children, any doubts regarding this? It's a very simple children. We can write any number, any composite number by using its prime factorization. Children, you can take this question as homework. Okay. So express 5005 of its prime factors. Okay. Next, LCM children. So what is the meaning of LCM? Any idea? So how we can find the LCM of any numbers? Actually, what is the LCM? So LCM means what children? It's the lowest common multiple, isn't it? So we can say that is least common and multiple. So that is called what? LCM. So what is the multiple first? How we can find the multiple of a number? Tell me children. How we can find a multiple of a number? So multiple means very simple children. The product of a number. So the product of a number and a natural number. The product of a number and a natural number. So that gives the what actually? The multiple of that number. You can take something 2. Otherwise you go a little bigger number. I am writing something what children? 7 I am writing. So 7 into 1. So 7 into natural number. You can take 7 into natural number. And you can take 7 into natural number. And you can take 7 into natural number. Okay. So this 7, this 14, this 21, this 28 and this 35. Okay. This all what we call children? The multiples of 7. Generally the multiple nothing but what? The number product into the natural number. So product of the number and the natural number gives the what children? The multiples of the number. See, by the way, you can easily find all the multiples of a number. You can write 7 is a one multiple, 14 is a multiple, and 21 is a multiple, 28 is a multiple, and so on. Okay. So these are all the multiples of 7. Clear children? Now my question is, can you tell me the multiples of 6? Tell me how we can find the multiples of 6. It's a very easy simple children. So just write down the table. 6, it is 12, 18, and this is what? 21, and this is what? 30, and 36, and so on. These are all what? Multiples of 6, isn't it? Now children, we have to notice some points here. The first point is what? Can I say every number is multiple of itself? Yes or no? So we can say every number is what? A multiple of itself. So I can say 6 is a what? A multiple of itself. Okay. And every multiple is greater than or equal to what? The given number. See, the 6 is what? Equal to number. And 12 is what? Greater than number. And 18 also what? Greater than of given number. And 24 also what children? Greater than of given number. So what we can say? Every multiple is greater than or equal to what? The given number. Okay. And one more point I wanted to add you children. We can write uncountable multiples. Like if you have some number is something 6. So how many multiples you can write? You can write uncountable. You can write as many as. There is no fixed count for these multiples. But factors are finite. But multiples are what? Infinite. You can write as infinite multiples. Yes or no children? You can write infinite multiples of a given number. So these are the 2-3 properties of the multiples of a number. Okay. So clear children, everything? Multiples. What is a multiple? How we can find the multiple? Any doubts regarding this? Multiple nothing but what? The product of the given number and the natural number. So that gives the what? The multiple of a number. Okay. So that is a multiple. But actually children, what we are learning? We are learning about the what? The least common multiple. We need to learn about the least common multiple. So multiple, we got the idea. Common means what, children? It should be present in the both the numbers. So that is called the word common. Okay, listen children. The least common multiple is also nothing but what actually LCM. That is the what? The lowest common multiple. But how we can find the LCM? The least common multiple of 2 or more number is the what, children? The smallest number among all common multiples of the given number. First of all, we need to write all the multiples of the, not all, at least you can write few multiples. After writing the few multiples of the both the numbers, just select the only common numbers, like common multiples of the given number, first given number and second given number. From that you pick up the lowest one. So the lowest common multiple we can say as what, children? LCM. So that is a basic definition of LCM. The lowest common multiple of the given two numbers. So that is called what? LCM. Children, let us see one example. I am writing that all the multiples of 2 children. Like, what is the multiples of 2? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 and so on. These are all our children, the multiples of 2, isn't it? Next, I have multiples of 5. I am writing all the multiples of 5. So what is all the multiples of 5? You can take 5, you can take 10, 15 and 20 and 25 and so on. Okay, you can write as 25 also. And you can write as 30 also. You can write as 35 also. Okay, these are all the multiples of what? 5. And see children, there are some common multiples in between the both the number, isn't it? Can you tell me what is the common multiples? So can you tell me children what are the common multiples in between them? Yes, there are common multiples. So I can say 10 is a common multiple and here also 10 is a common multiple. And I can say 20 also common multiple and here also what? A 20 is a common multiple. So 5 and 20 both are what, children? Common multiples of what? 2 and 5. But my question is, which number we have to select as a LCM? So we got the 2 common multiples, not only 2, we have the more than 2 also, but I am not writing all, just I am writing up to 2, like I am selecting only 2 as a 10 is a common multiple and 20 also a common multiple. My question is, which number we have to select as a LCM? So what is actually LCM, children? The least one we have to select. Among the 10 and 20, can you tell me what is the least one? The least one is what? 10 is the least one, isn't it? The least one is what? A 10 is the least one. So the 10 is the least one means we can say the LCM is 10 is the answer. Clear, children? Therefore the LCM is what? 10 is the LCM of what? 5 and 2. This is 5 and this is 2. Clear, children? Any doubt regarding this? How we are finding the LCM? First I am writing the all the what? Multiples of 2 and I am writing the all the multiples of 5. Then I am writing all the common multiples. So among them I am selecting the what? The least multiple. So the least multiple we can say what, children? LCM of the given 2 numbers. See children, any doubts regarding this question? Regarding this example? I hope it's clear for you, okay? Next children, methods of finding the LCM. So generally, how many methods we have to find the LCM? Children, we have exactly 3 methods. The first method is what? LCM by listing method. Just now we have discussed the same method by writing all the factors, all the multiples. From that multiples we are not selecting the what? The lowest one. Okay, that is the first method. And second one is what? By prime factorization method. And next one is what, children? LCM by using the what? A division method. Children, and first method and second method is no need to remember because already you have learned in somewhere what 6th class, 7th class, okay. But you have to follow only this method, children. That is what LCM by what? Using the division method, okay. So this method you have to follow, like whenever you are finding the LCM. So better you go for the last method. So that is what easiest and quick method, okay. Now children, let's just discuss one by one what is the listing method and what is the what a prime factorization method and what is the what a division method, okay. So we'll discuss one by one with examples. First method, children, by listing the method. So listing by method is what, children? In this method, to calculate the LCM of two R numbers. So two numbers means I am taking the A is the one number, I am taking the B is number. So what we do? By listing this method, we step the follow. So what are the steps? See. Step number 1. First, write down the few multiples of A and B. So when I am taking the A is the one number, when I am taking the B is the one number. So write down the multiples of A and write down the multiples of B. That is the first step number 1. And what is step number 2, children? Make the common multiples of both number A and B. After writing the multiples of A and after writing the multiples of B, we have to write only common one. So select all the common multiples of A and B. And what is step number 3, children? Select the smallest common multiple. Among all the common multiples, in that you just select the only the lowest one. So the lowest multiple is called what, children? LCM. So that is the what? By listing the common multiples method. Children, let us see one example so that you can understand better. See, I am taking one example, children, 4 and 5. So I want to find the word LCM of 4 and 5 by listing the word multiples. Now children, can you tell me what is the multiples of 4? And can you tell me, children, what is the multiples of 5? Tell me multiples of 4. What are the multiples of 4? Yes, so we can say 4 is a one multiple and we can say 8 is a multiple and 12 is a multiple. Next one, 16 is a multiple, 20 is a multiple. Next one, 24 is a multiple, 28 is a multiple, 32 is a multiple, 36 is a multiple, 40 is a multiple, 44 is a multiple, 48 is a multiple. Next, children, after 48, what is the number? Just add it. So this is something 52 is a multiple. And so on. There are many multiples are there, but I am not writing. I am writing only few. Then can you tell me, children, what is the multiples of 5? Yes. So multiples of 5 nothing but a 5 is a multiple, 10 is a multiple, 15 is a multiple, 20, 25. So 25 is a multiple, 30 is a multiple. Next, children, 35 is a multiple. Next, 40 is a multiple, 45 is a multiple, and 50 is a multiple, 55 is a multiple, and you can write as many as. Then children, after writing the multiples of like 4 and 5, you just circle all the common multiples, okay. Now children, I am circling all the common multiples. Now tell me what are the common multiples? Is a 20 is a common, here also 20 is a common. Next, 40 is a common, here also 40 is a common, isn't it? So after like circling the common multiples, in that you select the what, children? The smallest one. So among the 20 and 40, can you tell me, children, what is the smallest one? So I can say 20 is the smallest one, isn't it? Are you getting my point, children? Among the common multiples of 20 and 40, I can say 20 is the what? A smallest multiple. So we can say LCM is equal to how much, children? 20 is the answer. Clear? Any doubts in this method? This method is very simple, children. First, take the two numbers, write down all the common multiples. Don't write all, write at least 5 to 10 multiples of first number and write down the 5 to 10 multiples of second number. Then circle all the common multiples of in both the numbers. Then pick up the what? The smallest one. So the smallest multiple is called what, children, here? The LCM of the given two numbers. Okay. So that is the first method. Now children, let us see the second method also. So what is the second method? LCM by what? Finding the prime factorization. Let us see children this method. In this, what is step number 1? See here. Represent the numbers in the prime factorization. So write the complete number in the form of what? Its prime factors, like product of its prime factor. That is the first step. And second step is what, children? The LCM of given two numbers is the what? Product of what? Its prime factors. What? Product of its prime factor. But the thing is what? If the factor is repeating 2 times, we can take only 1 time. So that is the what? LCM by a prime factorization method. So let us see children one by one. By taking one example, so we can discuss this thing. Now children, I am taking the small example. I want to find the what? LCM of 60 and 90 by using a prime factorization method. Children, first find the LCM of like prime factorization of what? 60. Tell me children, how we can find prime factorization of 60? This is what? A 2 how many times? 2 30 times. And this is 15 times. And this is 3 5 times. And this is a 5 1 times. So children, 60 I can write as 2 into 2 into 3 into 5 into 1. So this is prime factorization of what? 60. Now I am doing same for the what? 90 also. Now tell me children. 2. 2 how many times? Here 2 45 times. And we'll go for 5 table, and 5 how many times? This is 9 times. And this is what? A 3 3s are, and you can take this is 3 1s are. So 90 I can write as children. Tell me how we can write? 2 into 3 into 3 into this is 5. So 2 3s are 6, 6 3s are what? 18, and 18 5s are 90. So that is what? Prime factorization of 90 children. Now children, what I am writing? I am selecting the what? A common factor. If it is common, select that one. If it is not common, select that one also. Okay. See children, here 2 is common. So write down the 2. Here 2 is present here not present. So it is take the 2 also. And children, see here 3 is present 1 time, 3 present 1 time. So take one more 3. But 3 here present one more time also. So take one more 3. And 5 is present here and 5 is present here. So take the 5 here. Then multiply now. So 2 2s are 4, 4 3s are 12, 12 5s are 60, 63 is 180. So what is the LCM children? 180 is the answer. Clear? Children, we have to multiply all the prime factors which is present, and which is, if it is present only in the one number, we have to consider that factor also. See children, what I am telling you. Here 2 is what? Repeating 2 times in the first number. Here repeating only 1 time in second number. Even though we have to take the 2 2s. Because majority is what? Here 2 is repeating 2 times. So that is the majority one. So that's why I am writing the 2 times. Coming to 3 here. Here 3 is repeating only 1 time. But here 3 is repeating 2 times. So majority is what? 2 times. So I am writing 3 is what? A 2 time. And 5 is repeating here 1 time. Here 5 is repeating 1 time. So I can take 5 as 1 time only. Then multiply all the prime factors. So you will be getting the answer is what? 180 is the answer. So we can say this 180 is the what? LCM. Clear children? Any doubts regarding this sum? First, factorize both the numbers, then listed all the prime factors. From that, select the what? Which is repeating and which is not repeating, and select the majority also. And select the factor if it is present only one number, even though we have to take that number. If it is present in only one number, if it is not present in another number, even though we have to consider as that factor. And multiply all the list of factors, then write down the answer. That will be our final answer. Clear children? Any doubts regarding this? I think question is so simple and there is no queries in this question. Okay. Now children, let us see the another question. Next one children, LCM by division method. So children, you have to remember only this method. So any problem we can go for only this method children. Okay. So what actually happened in this method? Let us see one by one. Step number 1. So what is step number 1 children? Listen here. So find the prime number which is a factor of what? At least one of the given number. Okay, write this prime number on the left of the given number. So generally what we'll do, you think it is A is the one number and you take as B is the one number. I want to find the what LCM of A and B. So draw one like horizontal line, anything, okay, horizontal and vertical line. So you select one number, children, here, so that it should be divide A number and should divide B number. Then after dividing this number, write down the quotient of after dividing the A and write down the quotient of after dividing the B. That is step number 1. Next one, after writing the quotient, so I am taking the something x is a one number. You think that this x is what dividing the A and x is what dividing the B. So after dividing the A, you got something quotient is something what x1. Again you got the something quotient is what x2. I can take one more number, something it is what y. So you take another prime number, something y, and this y should what divides x1 and y should what divide x2 also, isn't it? Again after dividing x1, you can take something what a1 is the what quotient of x1 and you can take b1 as quotient of x2. Then children, try this procedure where you get a1 and a2, like these two numbers are what co-primes. Are you getting my point, children? So do the same procedure till you get these two numbers are what co-primes. So once you get both the numbers are co-primes, then you can stop your division. After that, multiply this all multiples and divisors, quotients. Like this is one divisor, these two are what quotients. So this product is what completely we can say LCM of the given two numbers. Clear, children, this method? We'll do one thing, we'll take one example and we'll discuss, okay? Now children, I am taking one example, 80 and 100. So I want to find the what LCM of 80 and LCM of 100. Children, what I told you, you select the one number which should divide the both the numbers. So like that we have to select, okay? Otherwise you can start with prime numbers. If not, you can go with what composite number also. Children, what I will do, I'll go for directly 20. Can I say 20 divides 100 and 80? Yes or no? Because 20 is a what factor of 100 and 20 is a what a factor of 80. So I can say 20 is a common factor of both the numbers. So I can write this is 25 times and I can say 24 times. And children, look at here, this number 5 and this number is 4. Can I say do they have any like common factor, both 5 and 4? No, they don't have any common factor. Because 4 and 5 both are what we call, children, those are called co-primes. So if the numbers are co-primes, you can stop it here only. You don't need to do again division. Because there is no common number which can divide both the number except 1. So you don't find any other number except 1 where both the numbers are divisible, isn't it, children? So what I am doing, I am stopping here only. So stop here only. I am not moving forward. Because both the numbers are what? Co-prime numbers, isn't it? So co-prime numbers means there is no common divisible. There is no common divisor, yes or no? So we can stop here only. So at last what we have to do? Then LCM is equal to product of this. So you can write as 20 into, you can write 5 into, you can write 4. So 25 is how much, children? So 25 is 100 and 100 into 4, it is 400. So final my answer will be 400 is the answer. See, children, any doubts? First we have to select the number which divides both the number. So I am selecting the what 20. So I can say 20 is what divides both 80 and 100. Okay. Then I got the 5 as a quotient and here I got the 4 is a quotient. And select the number again which divides both 4 and 5. But children, I don't have any number which divides both 4 and 5 except 1. So that's why what I am doing, 4 and 5 are what? Both are co-primes. There is no any number which divides both the number. So I am stopping there only. Isn't it? I am stopping there itself. Why? Because I don't have any number which divides both of them. So at last what is my LCM? Multiply directly 20 and 5 and 4. So answer is what? A 400 is the answer. Clear, children? Are any doubts? It's a very, very simple method, children. So whenever you do LCM or else finding the LCM of any two numbers or three numbers, so go for this method only. It is the shortest method and you can find the answer very quickly. Okay. Next, children, in this class what we have discussed? So we have discussed about what? The fundamental theorem of arithmetic. That is the first method. And second one what we have found? We are discussing what? Introduction of LCM. So like what is the introduction of LCM? Okay, that is the next thing. Then methods of finding the LCM. The total how many methods we have finding the LCM, children? We have the three methods. First one is listing the multiples, and second method is what? Prime factorization method, and third one is the what? The long division method. So children, what I am telling you, just remember, otherwise practice only the last method, that is what? A long division method. Okay. And some problems we have discussed to find the what? LCM of the given two numbers. Okay. So that is the what? The complete summary of this class. Okay, children. Now let us discuss the few questions related to what? Again, finding the LCM. Children, look at this question. So find the LCM of the following integers by a prime factorization method. Okay. Now, children, can you tell me how we can write this 12? So 12 write as 2 into 2 into 3, because 2 2s are 4 and 4 3s are 12. And children, can you tell me how we can write 15? 3 into 5 into, you can write as 1, otherwise no need of writing 1, because 1 is a what? Is a factor of every number. So no need to write of 1. Then how we can write 21, children? We can write as 3 into 7. Children, first find a common multiple. Sorry, what is a common factor? What is a common factor? So 3 is a common factor, 3 is a common factor. So write down the 3. Next, children, here 2 and 2 is present, but here it is not present in 15 and 21, even though we have to write 2 into 2. Then children, one more factor is what? 5. So 5 is present only 15. It is not in present 12, not present in 21. So even though we have to consider as 5. And take one more number, 7. 7 is present only 21. It is not present in 15 and not present in 12. So write down the 7 also. Okay. Then product. So 3 2s are 6. 6 2s are 12. And 12 5s are 60. 67s are. Answer is what? A 420. See, children, any doubts regarding this prime factorization method? First, I am writing the what? Factors of 12. I am writing the factors of 15 and factors of 21. Then I am writing all the like product of all the factors, which is repeating 2 times. We are considering only 1 time. Why? Because see, here 3 is what? Repeating 1, 2, 3, like in the 3 numbers, but I am considering only 1 time. Then multiply all the factors. So that is our final answer. Okay. Let us see another question, children. Find the LCM, again same prime factorization method. Children, listen here. 17 and 23 and 29. So 17 and 23 and 29. Can I say these 3 numbers are prime factors, like prime numbers? Yes or no? 17, do we have any factors for the 17? No. 17 we can write only 17 into 1 only. And 23 also we can write as 23 into 1. And 29 also we can write as 29 into 1 only. Because these 3 numbers are what, children? These are prime numbers. So they don't have any common factors, isn't it? So directly what we do at the time? Directly multiply 3 numbers. So what would be the answer, children? So multiply 17 into 23 into, this is 29. So let us say multiplication also, children. First I am multiplying 23 and 17. 17 3s are 51. So carry 5. 17 2s are 34. 34 plus 5, it is 39. So 391. So this is what? A 391 into again 29. So multiply 29, children. So 9 1s are 9. 9 9s are 81. Carry 8. 9 3s are 27. 27 plus 8, 35. And 2 1s are 2. 2 9s are 18. Carry 1. 2 3s are 6. That is 7. So this is 9, 3, 3. And this is 10. So what is the answer, children? 10339 is the answer. Okay. So it is a finding the what? LCM by a prime factorization method. See children, any doubts regarding this question? Children, here all the numbers are given numbers are what? A prime numbers. For the prime numbers, we can't find any prime factorization because the number is prime number means they don't have any prime factors. Okay, so directly what I am writing 17 as I am writing 7 into 1, 23 I am writing 23 into 1, and 29 I am writing 29 into 1. Then I am multiplying all the factors. That's it. Then children, look at this question. We'll do one thing children, this will do by a long division method, okay, not prime factorization method. We'll go for what? A long division. Okay, tell me children how we can do by long division method. I told you already. So write down the 72 and write down the 108 and put the one bar type. Now children, can you tell me which number divides both 72 and 108? So that number we have to select. It should be what? A common divisible, isn't it? Otherwise we can say a common factor. So can you tell me children which number divides both 72 and 108? So what is the number? Can you guess and tell me? 72 and 108. Tell me children. Can I say 12? Yes or no? So 12 divides 72 and 12 divides 108. So I can say 12 6 and I can say 12 how many times? 9 times. Children, we got the quotient as 6, 9. Now can you tell me children which number divides both 6 and 9? Is it 2? So which number divides both 6 and 9? So it is 3 children. So what I am writing? This is what? A 3 2s and it is 3 3s. Children, see here this 2 and 3 both are what? A co-primes. Again you can't divide both 2 and 3. Isn't it? So what I am doing, just simply I am multiplying this all the numbers. So 12 into 3 into 2 into 3. So this is what? 12 3s are 36, 36 2s are 72. So what is 72 into 3 children? So this is 72 into 3. So 3 2s are 6 and 3 7 are 21. So what is the answer? 216. Clear children? What is the LCM of this number? Answer is 216. So children, I hope you understood this class and there won't be any doubts. Children, try to practice more sums so all the doubts will be cleared. Okay. So thank you children. Thank you so much for your valuable time.